Hello, my name is Chris Fierro, and I'm a student enrolled in the Bio 515 course, or Physiology 1, at Grand Canyon University. Today's presentation is on two hormones, the first being thyroid releasing hormone, and the second being thyroid stimulating hormone. In this presentation, we'll discuss and gain background information on the hypothalamus, the pituitary gland, and the thyroid gland, as well as the hormones produced by it, and how they work in a negative feedback fashion to control the levels of thyroid releasing hormone and thyroid stimulating hormone. The link to this video, or the link to the video for this presentation, will be inserted here. So the hypothalamus, and we can see it here in green, is located inferior to the thalamus and superior to the pituitary gland. So the hypothalamus is really important in helping the body maintain homeostasis via a number of different mechanisms. The hypothalamus, as described by Sherwood in our textbook, is an important link between the nervous and the endocrine systems. The hypothalamus is involved in the regulation and maintenance of many of the processes such as thirst, hunger, circadian rhythms, temperature regulation, blood pressure, learning, memory, sexual drive, and emotional expression, and other systemic activities. In this specific context, however, the hypothalamus is responsible for the production of hypophysiotrophic hormones, such as the one that we are discussing today, thyroid releasing hormone, which is a major part of the discussion, and we'll expand on that one shortly. The pituitary gland, once again highlighted here in green, is located just posterior to the hypothalamus, inferior to the hypothalamus. The pituitary gland is an important part of the endocrine system and consists of two separate lobes. The posterior lobe, or the neurohypophysis, and the anterior lobe, or the adenohypophysis. The release of hormones from both lobes of the pituitary is controlled by the hypothalamus, right up here. The posterior lobe of the pituitary is regulated by a direct neural link to the hypothalamus and releases the stored hormones when stimulated. The anterior lobe of the pituitary is connected to the hypothalamus via a vascular network known as the hypothalamic hypophyseal portal system, which I'll expand upon in the next slide. And as seen here, one of the hormones produced by the anterior pituitary gland is this thyroid stimulating hormone. This is a great image. It gives us, here's the direct neural link to the posterior pituitary. And then we can see here that vascular network, or the hypophyseal portal system, that is connecting the hypothalamus and the pituitary. So the hypothalamic hypophyseal portal system consists of capillaries found in the hypothalamus that recombine to form larger vessels, okay, that travel down the connecting stalk of the pituitary and then branch out once more to the capillaries of the anterior pituitary. It's through this vascular link that the regulatory hormones of the hypothalamus are transported to the anterior pituitary so that they can have their needed effect on that gland and its secretory function. This vascular link is vital for the hypothalamus to have a rapid effect on hormone release from the pituitary. If the pituitary had to rely on systemic blood, for example, to carry the hormones, the regulatory hormones to it, it would take a lot longer to have that needed effect, as it would need to be pumped from the heart through the body until it reached its destination in the pituitary gland. And it's here in the anterior pituitary where thyroid stimulating hormone is produced and released. And so it's here where it's produced and released from to act on the thyroid gland, which is important to the negative feedback mechanism acting on the pituitary and the hypothalamus. So here we see the hypothalamus pituitary thyroid axis. So we see all three of these glands shown here. We have the hypothalamus, the pituitary, and the thyroid gland here. So the hypothalamus pituitary thyroid axis is the relationship between the hypothalamus, the pituitary gland, and the thyroid gland, and the hormones that they release. So here we see the thyroid hormones, we see thyroid stimulating hormone, and then we see TRH right here, or the thyrotropin releasing hormone. The hypothalamus and pituitary form a number of different axes with other target endocrine glands, such as it does in this case with the thyroid gland. But other examples are the adrenal glands or the gonads. So this link or this axis right here is typically referred to as the hypothalamus pituitary target organ axis. So it just kind of depends on which gland it is targeting, and that'll determine its name. So here in this respect, it's the thyroid axis. In this image, so here in this image, we can see that relationship between the hypothalamus, the pituitary gland, and the thyroid gland, along with the regulatory hormones involved. As mentioned earlier, the hypothalamus produces and releases thyrotropin releasing hormone, which is considered to be responsible for setting that HPT access point in terms of its regulatory properties. Okay, so it's this hormone, TRH, that is considered to be responsible for setting kind of the set point for this whole axis. So TRH binds, right here, TRH, binds to G protein coupled receptors on the plasma membrane of the anterior pituitary, where it regulates the production and release of thyroid stimulating hormone. The thyroid gland is reliant upon proper TSH levels because low levels of TSH are result in hyperthyroidism, meaning that there are high levels of thyroid hormone. And then high levels of TSH, so if we have high levels of TSH in the blood, indicate that someone has hypothyroidism, as the thyroid gland is not producing enough of these thyroid hormones to lower TSH levels. In a proper functioning HPT axis, levels of TRH and THS are controlled by the levels of circulating thyroid hormones via this negative feedback loop mechanism as noted here in the image. So we need these hormones to regulate these other two hormones. The more of these that there are systemically, the less TSH that there is. So, and then just on a personal note, I chose this specific topic because I have hypothyroidism. And part of my goal with doing this presentation was to learn a little bit more about the physiology of the disease. So in my reading, hypothyroidism is somewhat rare in males in terms of in a comparison with females. And one of the ways, so I control it by taking thyroxine to keep my TSH levels steady, because they were pretty high before starting to take thyroxine. And here are my references. Thank you so much for your time, and have a great evening.